Third round of applause for Luke.
Hello. Okay, cool. All right. Hello, everyone. My name is Luke. I'm first time at SydJS. Just moved to Sydney, actually, like 3 weeks ago from far north Queensland. And today I'm going to talk about adventures of the expand text area and Luke Donnet. Who's Luke? All right. So I'm a senior software engineer at Safety Culture. I've been a software engineer for about 6 or 7 years, depending on how you want to count that. Previously to software engineering, I was a chemical engineer working at a pharmaceutical company making green replacements for certain drugs and compounds. Before that, I was an ex-music critic for a heavy metal website. So yeah, bands and stuff used to send me music from around the world, so that was cool. And I was a martial arts teacher for about 12 years and did some kickboxing along the way. So if I'm a little bit slow, that it might be from that. All right, why expanding text areas? So, text areas, text inputs, they all look like really simple elements. And at least when the first time a jury ticket came through and said, hey, build this expanding text area, it seemed very deceptively simple. We estimated it low, but as we went through sort of the journey of building it, we learned that there was a lot more nuance to it. But why would you want a text area to expand? Well, sometimes it's just the right fit, depending on the screen size, depending on the use case. A text area that grows with the input might be what you need. However, it is very, very challenging to get very specific behavior. If anyone has dealt with text areas, you'll know that the API is very limited and it's very annoying to use. So you'll need to know a few tricks. And yeah, on the journey of creating a expanding text area, I learned a lot about the browser, how browsers render elements. And yeah, we're going to go through that same journey today. So to set the scene, what are the requirements for our text area? So it should do 3 things. It should start as a single input, right? That's a pretty easy one. The text area element gives us this functionality by default. Secondly, as the input grows, the text area should also grow. Now this one's a medium because we know based on just the normal API that it gives us, we can't do that, but we can still get information from the text area to make it grow. But the last requirement, if the input grows to more than 8 lines, it should start scrolling. Okay, this is where we need to open up our bag of tricks and do some, I wouldn't say magic, it's more like a Picasso style thing, and then we convince people it looks good, something like this. Anyway, all right, let's have a look at what the end result looks like, and then we'll dissect it. So here's one I prepared earlier. Does everyone remember like the old cooking shows where they'd be like making dough or something, and then they'll be like, oh, well, after waiting 4 hours, you have one that gets prepared. Sorry, it's gonna change tab. Where am I? Okay. All right, this was not as seamless as I was hoping. All right, text area. Hey, it expands. Oh, and then when we get to 8 lines, it stops and starts scrolling. And so it's got some other functionality. It works with white space, so it doesn't matter if you've got one continuous line, it will do the wrapping. If I enter multiple paragraphs, it will also behave as expected. If I cut, how do I? Used to my keyboard shortcuts. Whoops, that was the wrong shortcut. But if I cut this, and then paste it, it will work as behaved. So which should do all the normal functional things that you would expect a text box to do. So that's the demo. Let's have a look at what's happening under here. So this is all built in React. We have an expanding text area component. Where is this? Good question. So funny you mentioned that. I was going to do it in TypeScript, but it was called, this event's like SydJS, not SydTS. So I was like, yeah, let's just use JavaScript. Although if it's SydJS, it should be SJSJ or something, I don't know. All right, so we have an expanding text area. Now, the first thing that I want to point out is the render function. Notice here we've got two elements. We've got our text area, but we've also got another div, okay? And this is called the text area mirror element. So basically, the approach that we're going to take here is that because the text area itself is very limited in its functionality, we're going to mirror the contents of the text area into a div and then do all of our measurements based on that, okay? So we have a text area that has a value that will change and we save in state, text area ref, and then we reflect that value in the div. So by default, the text area styling doesn't match the default styling of what you would expect from a div. So in order to make that mirror, basically what we're going to do is we're going to get the computed styles of that text area and then apply them to the div. So if we go up here, basically the sort of styling that we want to pull out is anything that influences the format. So anything that, because we need to calculate the number of lines, we want to pull out anything that would affect the wrapping. So for example, we want to take the font, we want to take the white space. So if I just show the mirror, we can see that, oh, I didn't save, apologies. Should be able to see the mirror. Oh. You can see that as we type, we actually have the exact same styling, yeah? So now we can do our calculations. And you notice that as I'm doing my typing here, this thing will not scroll itself, but it will continue to show what the actual size of the input is. So now we can actually do the calculations based on this div. So if we go back, so the first thing we do is we save the text area ref element. We save the text area reference into a ref. And then we get the computed style of that text area element. And then we create the mirror style. So this is the ones that we want to reflect. And then from there, we add it to the mirror element. Now, what's interesting here is that we're doing an object assign, not adding the style object directly to the style of the mirror. And that's because the style property of a HTML element is read-only. So we can't just reassign it, but what we can do is we can copy the reference and the values into the style itself, and that's what we use object assign to do. And then once we have got our mirror, we can now start doing our calculations. So we really want to just understand what the height of the text is and how big the text area is, and then from there we calculate the number of lines. So we want to subtract, we want to do that calculation. We want to get the offset height of the element, but we want to also subtract the padding, the border, and that sort of stuff as well, so we can accurately calculate the number. And then once we're there, we can set the number of lines, and then we can do some, it's just a mathematical operation from that point. So if we're over the set line limit, then we start scrolling, which is what text areas by default once they reach the row limit. Cool. So okay, cool. All right, so we just showed the code. Now, when building mirrors, the get computed style really is the source of truth for what the browser renders. So definitely learn on that as much as possible. it's a bit of a risk sort of relying on what is in the style sheet that you have in the code. It's not the source of truth. And then from there, you want to extract the relevant dimensions that you use in your calculation. And notice that the values that are returned by the computer style are actually in raw pixels. They're not in relative units. We'll see why that happens, or why you get that, why you get absolute values as opposed to relative values in a second. Now, there's some interesting gotchas with using computer styles. One of them is that some values are not parsable, or some values that you would expect to return as numbers are not actually numbers. So for example, line height, by default, the browser will return it as a normal string, even though when you set it as a CSS property, it's a number. And that's because the line height is very dependent on a lot of things, such as the font size, and those sorts of different dimensions. And you can use another ruler if needed. So the Miro really is a ruler to do calculations. And is this going to show again? And you can see here that because we can't get the line height properly, we need to count number of lines, and the line height is normal, we need to create another ruler, and that's what we do with the span. So basically, I take the first character of the string, calculate its height, and then put that into the calculation as well. And the beauty of line height is that it's constant for every character. So a lowercase s is not a different dimension to an uppercase s. All right. And also beware of fractional pixels. So particular mobile browsers, pixels are not absolute. I was shocked to find out that the lowest atomic unit of a screen can be divided, which is weird. But that's why you want to use parse float instead of parse int, because you'll crash your front end if you try and parse a decimal into an integer. But if you notice in the demo, there is a small problem here. Can anyone see? Actually, if I go, whoops, I just gave away the answer. Jeez. All right. But can anyone see what the problem with this is? Even though I gave away the answer, it's still interesting to explore why that's the case. Maybe if I throttle my browser. Sorry, I'm still one-handed. If I throttle my browser, can anyone see a problem with this? The delay, exactly. Who said that? Any guesses as to why the delay is happening? Yep. Well, let me rephrase the question. Why does using the other thing help in this scenario? Correct, right? So the problem is actually this use effect. The key thing with use effect is that it's asynchronous, meaning that when you update state in your React component, it's going to immediately start rendering, and then at some point in the future, this will finish and then apply its styles. So what we see happening is the reason why the scroll bar is coming in is because the value gets updated, it needs to expand, and then the computation for the measurement runs, and then it decides that it needs to expand again, okay? So we can fix that by using use layout effect, okay? And if we look at the one-handed typing again, if we look at the doc string for this, the signature is identical to use effect, but fires synchronously after all DOM mutations. Oh, it's actually good. They added more docs this time. Before it used to say runs before paint, which was completely like, what's a paint? Like, what is this? Okay. But going into that deeper, we can see that in CPU limited environments, when you get this sort of race condition, you can get some weird glitches. So if we use layout effect, basically what happens is that any computations will run before the browser actually prints something to the screen. And below here, I've got part of the render lifecycle of the DOM of the browser. So you can see that first we start with the DOM, then we compute the style. So the computing style is when we turn those relative units into the absolute ones. So this is why get computed style gives you pixels instead of percentages. After that, it does the layout after it has all those calculations. And then there we can calculate the heights and widths. So even though the screen hasn't shown the div that it needs to measure against, it's done all these calculations at this point, and therefore we can use them to render subsequent stuff. And it triggers a reflow event. That's which is why we don't see it jump twice, even though this is happening twice. Okay. So that's a bit of magic for the expanding text areas. All right, so use text area mirrors as rulers. So ruler element is just any element that you use to measure a dimension. So this is just one use case or how you can use a mirror as a ruler, but you can use them for anything that simplifies your geometry calculations. Be aware of what computer styles evaluate to. It's a common mistake to forget about the fractional pixels, for example. Use layout effect for computations that require calculations based on existing layout. So for example, if you have a tooltip, instead of just showing the tooltip above, what if your element is already too high? The tooltip can't go above. You've got to figure out that, hey, I've got to calculate, I don't have enough space, let's show it below. You'd want to use layout effect for that. And then evaluate effort for the user experience, because while this might not be a fit for every use case, there are some use cases where it is. So thank you for listening. Feel free to follow me on GitHub or LinkedIn. But if you really, really, really want to follow me, the best way to do it is join Safety Culture. So there's a few of us here, and yeah, don't be afraid to say hello. And yeah, I'll be sticking around for any further questions or criticism or pizza or beer or whatever. All right, that's me. Thank you.